Hello guys, glad to see you all here. Our today's topic is Java build tools and their comparison. My name is Danilo Vorotintsev. I'm a senior software engineer in EPAM, and I've been working in this company for 3.5 years. Let's first discuss why do we need build tools in general. When we have a program, we can use default Java commands to build it, to package it, and to deploy it somewhere. We can use javac with file names to compile our Java code, and then use jar with the C and F flags to assemble one big jar file. Why this approach isn't good for us now? Well, because it doesn't scale well. If you have 100 or 1000 classes, you have to specify them all manually in the Java commands. You have to manage your dependencies manually, and so on and so forth. So Java build tools were invented to address all these issues. Build tools can automate the process of compiling, building, testing codes, and deploying artifacts to some artifactory or web server. And also build tools can automate dependency management. It's a very important feature. We will see later why. Java is a pretty old language. It has a huge variety of build tools. So to name a few, there is Ant, Maven, Bazel, Boot, Bug, Gradle, Ivy, and many, many more. We will see just 3 of them. Why there are so many tools at all? Some companies may decide that popular tools are not enough for them, and they may decide to create their own tools and then maybe publish them to the open source. So probably you can too create your own build tool if you don't like the default ones for some reason. But I think in 99.99% of cases, it's much better to use something default that is well tested and developed for a long time. Let's see a bit of history of Java. First, when Java appeared, there were no build tools for Java, and make was used to assemble projects. Some of you may know Make. It's a tool that is currently used for C and C++ projects. When I prepared this light talk, I only then learned that Make was used with Java, so it is not used for Java for, I don't know, 20, maybe more years. So it's totally deprecated, but it's a part of our history. Then Apache Ant appeared. It addressed a lot of problems of Make, but nowadays no one uses it too. I haven't heard a project that uses Maven, that uses Ant, so it's deprecated also. Then we have Maven. It appeared after Ant, and it addressed some problems that Apache Ant had. One of the major features that Maven introduced was dependency management. With Maven, you can just specify the version and the name of library that you need for your project, and Maven automatically downloads it, maintains copy somewhere locally, and you don't need to bother about it anymore. Before Maven, in Ant and Make, you had to download a third-party jar file yourself, place it somewhere in the nearby folder, and specify all the paths for your libraries. It was very tedious and, well, error-prone approach. Maven is currently widely used in many projects, but we have one more tool that appeared even later. It's Gradle. Gradle addresses many problems that Maven has. For one, Gradle is the first Java build tool, at least the first popular Java build tool that doesn't rely on some XML file. Gradle relies on programming languages like Groovy or Kotlin. You can choose one, and you specify the build using real programming language. It's very handy, and we will see soon why. Yeah, nowadays Maven and Gradle are widely used, both of them. Let's see Ant, Maven and Gradle in more details. Ant was released in the June 2000, so it was 22 years ago. It originated from Apache Tomcat project. It was a part of it, and then it became a separate project. Build is described in build.xml file. Ant has many features. For example, it's really flexible. It doesn't impose any conventions on file structure, and user can control every step of build in the finest details. Also, Ant is very extensible. Disadvantages of Ant, yeah, as I said, it doesn't have dependency management. It's just a build tool. And each step must be explicitly configured. So the configuration for a big project becomes really, really huge. Build.xml can contain several fields. Well, I will name 3 of them. First, it's targets. Target is an Ant's name for task or job. Targets can depend on one another. For example, in a simple Java project, one target can be to compile Java classes, the second can be to assemble jar, and the third one to push this jar to some artifactory on a remote server. Build.xml can also contain properties. These are just string constants that are used to avoid duplication of file names and well, other constant strings. And also, build.xml can have paths. Well, paths are just like properties, but they're not for simple strings, but for file paths. Each target has its own set of properties based on its type. I will see it a bit later. And you can call the default target with a simple AND command, or specify which target you want to call with AND and target name. Okay, let's see a small demo. So I have a project with one main class. I use the same main class for all 3 demos, for all 3 build tools. This main relies on Google Guava popular library, so it has to be imported to my project to build. In main, I just do something, doesn't really matter what I do, with string hello world, and I just print the result. This program should output hello world string. Okay. In builds.xml, I have, well, the outer tag specifies main info about our project. So my project has a name andsample, it's a base dir of current directory, and the default target is build. So if I just run command and, it will build my project. Then I specify a bunch of properties, so I can reuse them later. I specify the directory of my source code, so it's just a folder source, build directory, classes directory, and yeah, here I specify to which directory and should place my assembled jar file. And here, as you can see, I can reference other properties that I specified before. Also, I have to specify a folder where all my downloaded libraries exist. So if I open it, here you can see that I have Guava 31.1. I had to download it manually. Okay, then I specify a path for my class path where all my libraries lie. And I just reference my libraries directory and include all files that end with jar extension. Then I specify a bunch of targets. The first, the basic target is compile. It has a description, compile project, and several steps. The first step is make dir. If you're familiar with Linux, you probably know this command. It creates a new directory if one doesn't exist. So I create a new directory where my compiled classes will be placed. After this directory is created, I call javac, specify where all my sources lie, where the output should be placed, and I specify the class path with all my libraries. Another target is jar. It depends on compile. So when you run jar target, it will automatically run compile target. Okay, oops. This one creates another directory and then assembles all my code into one jar file, places it where I specify, and also I create a manifest to specify the main class for this jar. Another target is to run this jar with a simple Java command, specify the main class and class path. Yeah, also I have an empty target named build that is default target for this project, and it simply depends on jar. It doesn't do anything itself, it just runs the jar target. And the last one is clean. It removes all the build classes. If I open console, I can clear it. Let's run just simple ant. It compiles classes, assembles jar, and well, executes empty build target, and then I can call ant run to see my hello world from Java application. So ant can be used, it still works, but it's quite difficult to write all of these configuration for huge projects, and also downloading libraries manually is a bit difficult. So please don't use ant. The next tool that appeared was Maven. It was released in July 2004, and well, main purpose was to cover problems of ant. The build is described in pom.xml file. Among Maven features, we can name extensibility. It supports a wide range of plugins. You can write your custom plugins. Yeah, Maven is 18 years old, and everything that you may need was created as a custom plugin that you can reuse in your projects. Also, as I mentioned earlier, Maven introduced dependency management to Java tools. So it's super cool. We'll see it in a bit. Disadvantages, well, Maven doesn't have that many disadvantages. Maybe one of them is that your configuration becomes too big for big projects too, because you use XML file. And also, in order for you to import a dependency into a project, this dependency must be present in a Maven repository. So it's not really a disadvantage, maybe. Okay, as I said earlier, ant doesn't impose any restrictions on the structure of the folders. So you can place your classes whatever you like. Maven, on the other hand, introduces a default project structure. So in the root of your project, you have a pom.xml file that describes all your project, how it should be built, etc. In the project's root directory, you also have a source directory that has two subdirectories, main and test. Main is for your well, production classes. These are classes that run through main and that execute your business goal. Code is placed in the Java subfolder, and some resources, for example, configuration files, locale-specific files, etc., are placed in resources. Test folder, as you can understand, is for tests, mainly for unit tests. It has the same structure as a main folder. It has Java and resources, but yeah, here you should place only your unit tests. POM.xml is an XML that specifies everything about your project, how it should be built, dependencies on the external libraries, the build order, and the required plugins. Okay, let's talk a bit about Maven repository. As I said, for you to import some library into your project, this library should be found in the Maven repository. Repository is a location, usually a file system. It can be a remote or local, where Maven artifacts are stored and managed. Repositories can be public, where anyone can access them, or private. For example, access is granted by password or for a subset of IP addresses. It can be used inside the company or for project-specific repositories. Stored artifacts can be retrieved and included into other Maven projects. There is a bunch of public repositories that you have probably already used. The most popular of them is Maven Central Repository. It stores, if I'm not mistaken, more than 14, or is it already 20 million artifacts. So it's a lot of different libraries of different versions. Yeah, and I would say that 90 or 95% of libraries that you need for your development can be found in Maven Central Repository. Also, there is a Sonar type releases. It's a repository where you upload your artifacts before you promote them to Maven Central. So maybe you need to do some checks, a security check, code quality check. You upload your jar files to Sonar type releases, and then you promote them to Maven Central. I haven't used Sonar type releases in production, but I think I uploaded one of my pet projects to Sonar type releases. Yeah. And the third public repository that I wanted to mention is JBoss. Some libraries decide to publish to JBoss, not to Maven Central. And in some rare cases, you have to include JBoss repository to your project. So these libraries can be found. And also, when you specify a new dependency in your project, Maven downloads the jar file and stores it into local Maven cache, local Maven repository. It's a well, .m2 folder in your user's home directory. By caching all of the dependencies, Maven doesn't need to re-download them every time you build your project. Okay. What are Maven lifecycles and phases? Maven uses the notion of lifecycles to manage its jobs. Lifecycle is just a container of 4 phases. There are 3 built-in lifecycles: default, clean, and site. Default handles project deployment. Clean just cleans the compiled, cleans caches, cleans compiled classes, etc. And site handles the creation of your project's website. Each lifecycle is defined by the list of phases which are executed sequentially. And each phase is made up of a set of goals. Goals are like steps in ANS target. So just create a directory, compile Java classes, and each phase may contain many goals to achieve this phase. And sometimes Maven goal can be not bound to a specific phase. Also, we mentioned plugins. Plugins are just a set of goals that may be and may be not bound to phases. Let's see a demo for Maven. Where is it? Yeah, okay. So I have the same main class. I will open it. Yeah, here, unlike with ANT, IntelliJ IDEA understands that I imported Google Guava library to my project, and it highlights it like it's present in my project. Okay, I open my pom.xml. This file controls all my builds for the project. The top tag for this file should be project that specifies some constant properties that are needed to validate your pom.xml. This text allows this auto-completion. So if you write something, IntelliJ IDEA proposes you what you can write here. Then we can specify model version, some information about our project, so group ID, artifact ID, and version, some project-wide properties. So here I specify that I use Java 17 and UTF-8 as a source encoding, and there may be other properties too. Then I can specify additional repositories. So Maven Central is imported by default, and here I decided to add GBoss repository. For it, I place a tag repository, and here I have to specify an ID and URL. This repository is public, so I don't need any passwords or logins. But if you add, for example, your internal project repository, you will have to specify here some credentials that are used to access your repository. Okay, then we have a bunch of dependencies. Each dependency is a separate tag. Here we specify the group ID, the artifact ID, and the version of the dependency that we need. So if I change here the version of the dependency, first IntelliJ IDEA knows what dependencies of this library exist, and it just suggests me different versions. If I change the version, press load Maven changes, new version will be downloaded and cached in my local repository, and I will be able to use it. But I don't need it. 31.1 is okay for me. Okay. Also, Maven has a notion of dependency scopes. So by default, the dependency that you import is available for your production code. So in a source main, your classes can use libraries that you import. But for some libraries, you don't need them in your production code. So here I have a JUnit API library that is used for unit testing. I need this library only in my unit tests. I don't need to import it to my production codes and pollute it with some redundant dependencies. So here I specify the scope test, and this library is only available for my test classes. If I try to use some classes annotations from this library in my production codes, well, they will be in red and my project will not compile. Default dependencies are available in tests too. Then we can specify our plugins and add some information about our build. By default, Maven doesn't have that many features, so you have to import them using plugin. So here, for example, to assemble a jar file, you have to import Maven jar plugin and configure it. So to import plugin, you specify group ID, artifact ID, and maybe a version, and then you specify a configuration. Configuration will be different depending on the type of plugin that you use. And for jar plugin, you have to specify the manifest and main class, so it will be added to your jar file. Okay, and one more example of a plugin that I want to show you is the following. For example, I have some file that is called foo.bar, and during my build, I want to copy it from the root of the project to my resources folder. in Maven, I cannot call just some simple codes. I cannot write some simple code that moves or copies file. For that, to copy a file, I have to import a plugin, copy, rename, Maven plugin, whatever you can choose. Another plugin, I think there are tens of them. And I specify that during the execution, during the phase generate sources, add a goal copy that will execute this plugin with the configuration from source file foo.bar, copy it to destination file source main resources foo.bar. So there are from the 52nd to 69th, so it's 18 lines of code to just copy one file. Yeah, Maven configuration can be a bit too long. Let's call this plugin. I can call phase Maven generate sources. It's executed, and if we take a look, yeah, I have my foo.bar file in resources. Yeah, that's probably it what I wanted to show you about Maven. Let's go back to the presentation. Before switching to the next tool, I would kindly ask you to subscribe to our channel, maybe press likes, and if you have any questions, you can ask them in the chat. We will try to answer all of them during our Q&A session. And also, we would greatly appreciate if you go to our VR community page that was sent to you in the email and rate this talk. It really helps a lot. Okay, let's talk about Gradle. It was released in the April 2008, so it's 14 years old, pretty old tool too, and it was created to fulfill the problems of Maven. Each new tool fulfills the problem of the previous tool. Build is described, as you can see, in build Gradle or build gradle.kts file, depending on the language that you choose. It's either Groovy or Kotlin. And finally, Ray, it's not an XML document. Gradle has a lot of features. First, it's a Groovy or Kotlin DSL. Instead of writing XML, you can write normal code. Gradle uses cache to run only tasks that have changed since the previous run, so it's often faster than Maven. Gradle supports Maven conventions, but you can override them. So if you have a Maven project with a Maven folder structure with a source, tests, etc., you can reuse the same structure for Gradle. And well, I would say that it's considered best practice to use the same folder structure in Gradle builds too. Gradle is highly customizable with plugins as well as Maven. It's also an official tool for Android development. It was chosen by Google some years ago. Also, Gradle supports a Gradle wrapper. It's a script that can be used to avoid manual installation of Gradle on your local machine. And it supports different repositories type, including Maven repositories and Ivy repositories. So you can reuse all your Maven libraries and import them to your Gradle project. Gradle has some disadvantages. First, it's a complexity. Instead of writing simple XML code, you have to write real code in Groovy or Kotlin, so there is a learning curve. Also, flexibility that Gradle provides isn't always required, especially for small projects. Okay, let's now see small demo with Gradle. So when I created this project, I chose Kotlin as language for my configuration. Groovy configuration would look pretty much the same, maybe with small differences. But yeah, I think Groovy is more popular, so I chose Kotlin, so you can see how this configuration works. Gradle provides very few tasks, very few opportunities by default. So you have to include plugins for it. Without plugins, you can't really manage projects, big project with Gradle. So here we include a plugin with the name Java. It includes tasks to compile Java, to run tests, etc. Then we specify our group and version of our artifact. And here we can also specify artifact ID. Yeah. Then we can add some repositories. So here I specify that I want to use Maven Central repository and also Maven repository with the following URI. So as you can see, it's a JBoss repository. Yeah, so it simply includes a repository into our builds. Dependencies work pretty much the same as in Maven. Maybe there are some differences under the hoods, but they are pretty subtle. First, you can import any library with a few lines of code, then in Maven. That's one of my favorite things of Gradle. So you can here write just implementation and specify the group ID, artifact ID, and version of the library that you want to download. It downloads it and it caches in the same Maven repository, local Maven repository as Maven does. And also Gradle has pretty much the same notion of scopes. So here I import Google Guava for my production code, for my main code, and also I can specify that this JUnit Jupyter API library I would like to have only for my test. So again, it will not be available for the production code. 1 line per dependency, it's pretty short, pretty concise. Then we can configure the tasks that we imported by the plugins. So for example, I have a task with name test of type test. So yeah, Kotlin supports strong type checks during while you write your code. And for this task, I write a configuration. I tell it to use JUnit platform. Also, in Gradle, you can easily create your own custom tasks. So here I have a custom task of type task. Task is like a parent class for all tasks. You can reuse some child classes, for example, copy task if you need to copy file. But I don't need any complex things to be done with this task, so I extend it from the task itself. I give it some description, some group, and I can tell it when this task is executed, write hello world 10 times. So this may be not quite familiar or cycle for you if you just code it in Java, but it's just a cycle how it's written in Kotlin. Okay, tasks may depend on one another. So here, my compile Java task depends on my custom task. So every time I compile Java, I will print hello world to the console 10 times. And also, I'd like to show you how easy it is to do some things in Gradle, which are quite difficult to do in Maven. So here I create a new task. I name it copy foobar, and it copies my file from root foobar into source main resources. As you can see, it's only 4 lines of code, and you can specify what you really need without importing some plugins. You can use real programming things like cycles, if branching, etc. Let's run something. So I will clear the console and let's do Gradle. Yeah, I use Gradle W. It's a Gradle wrapper, so it like encapsulates the calls to Gradle. And what should I call here? Let's see. Yeah, let's run compile Java. Compile Java. Runs, yeah, and as you can see, it writes hello world 10 times. And also we can execute copy foobar. Here I don't have anything in the resources, and we just print Gradle copy foobar. Execute this task. I hope it works. Yeah, and now and now this folder has my wonderful file. You may think that this example isn't really related to work. How often do you need to copy some files? But in fact, big projects usually need some custom task that can be easily written with Gradle, much easier than with Maven. So in my previous project, we had several tasks that copied files. The project was pretty big, and well, it was the easiest way to handle this problem, just to write several tasks that copy the required files. Okay, that's probably it, what I wanted to show you. Okay, let's see the comparison of Maven and Gradle. Configuration file for Maven is pom.xml. For Gradle, it's build.gradle. Performance of Maven is a bit worse. Gradle is better because it uses caches that track changes. Configuration in Maven is written in XML. For Gradle, it's a Groovy or Kotlin DSL. Lines of codes. Maven is longer because XML has more duplications than DSL, so Gradle is much shorter. Complexity, it totally depends. I have read several sources. Different sources have different opinion, but in general, they say that it totally depends on the project. Maven can be easier for smaller projects, Gradle for big projects, but maybe you have such requirements that Gradle would be easier for all projects, or Maven will be easier for big projects. Okay, and the last question, the last slide that I have, so you have time to ask questions in chat. How to choose a tool? The answer may be different depending on the person who answers. My answer is the following. Gradle is a good selection for new projects. It's faster, more readable, shorter. You can use Kotlin and Groovy programming languages. It should be easier to create custom plugins and so on and so forth. But Gradle, as we mentioned earlier, has some learning curve, and it may be difficult to just start up a good project with Gradle. If client already has other projects that are built with Maven, it may be a good idea to continue using Maven. Also, you may select Maven if the team has more experience with it and the deadlines are pretty tight, so you don't have time to study something new. Maven has been around longer and more people are familiar with it. But still, if everyone knows Maven, it can be a good chance to learn a new technology. That's it from my side. Do you have any questions? I'll try to answer them all.
Yeah, we have some questions in our chat. Let me read them. First question is, does the path values should follow Windows or Unix standards, or does it fully depends on the server we are deploying?
I think this is a question about ants. It's a pretty difficult question for me because I have never worked with ants. I would say that it depends on the system that you work on, but I'm not sure. Maybe under the hood, ant translates the path depending on the system you use.
Okay, thank you. Next question is, what ant problem does the Maven cover?
Yeah, actually it covers several problems. First, it's dependency management. It's a very huge advantage of Maven over Ant. Also, Maven has some notion of convention over configuration. So it imposes some defaults on the folder structure, and so default jobs can have less configuration because they assume that you have this folder structure, and they will try to look for your source code in the source/java/main, etc. You have less configuration, and yeah, you can use dependency management. Maybe there are some other things that Maven has, but I'm not that familiar with Ant to highlight them now.
Yeah, I agree. And maybe the last, it's not a question, but the comment, if you have any other questions, please pause them. The last comment is, Maven has a wrapper too, no need installation.
Yeah, I totally agree. Yeah.
Yeah. So as we don't have any questions in the chat, just one comes. Are there any differences in Gradle and Maven dependency conflict resolving?
It's a pretty good question. I don't think that I will be able to answer it right away. Tatiana, maybe you know the answer.
Let me think. Yeah, I don't know how to do it under the hood, but I believe there are such tools in your um, uh, um, you have used all of them have some tools to see which conflicts you have in the chat in the file, and to find what is the problem. Yeah, hopes that answers the question. Maybe we can just add some comments after the after our translation ends.
Yeah.
And yeah, one more question is following. One of ways of deploying var file to Tomcat is to manually copy and paste the var file to the webapps folder of Tomcat. Can we use the copy task to deploy to Tomcat with the task?
Yeah, sure, you can. There may be a problem with Tomcat deployed on another server, but for local development, you definitely can. After the var task, create a copy task that just copies this file. And for some clouds, well, yeah, in real life, you don't build vars on your local machines that are later deployed into production. And some CI/CD tool can use this task, but maybe it's not best practice to use it in production.
Yeah, I agree. So yeah, no questions for now. I think we can end our light talk. Thank you everyone for participation, and see you next time.
Thank you, guys. Bye.